Welcome to the lecture on descriptive statistics and descriptive research. This is actually a combination of two chapters in your textbook, and it's actually the second time I've recorded this today. However, the first time I recorded it, which was a pretty smooth recording, I thought, until I went to produce it using the software that I used, and it didn't work, and then I lost the file. So here we go, round two, and I'm going to try to move through this, not quickly, but move through it at a pace that I think you can understand it without spending too long on each slide. So our objectives for this lecture are to identify the common types of descriptive research and to begin to look at several options for organizing and graphing descriptive data. Within this, we'll look at central tendency, variability, and some different ways to do those kind of things on SPSS and Excel. So, an overview. We've talked about experimental research, talking about the future, and descriptive research, talking about the present. It's conducted to describe a present situation, what people currently believe, what people are doing at the moment, and so forth. It may or may not involve hypothesis testing. Answers the question, what is? What are they doing? What do they believe? And if you choose to do this kind of research for your proposal, like I said, it could include a hypothesis, or it doesn't necessarily have to have one. Consider a study in which there are 10,000 high school seniors selected from a population and surveyed as to whether they smoke tobacco, and 38% indicate they do. The researcher would report that 38% of high school seniors in the population smoke tobacco. And just an example of how you might use a research hypothesis in descriptive research. Using the same research procedures, the researcher could have hypothesized prior to conducting the study that 30% of high school seniors in the population smoke tobacco. In this case, the researcher reports a 38%, and whether the research hypothesis is accepted or rejected. Descriptive research is commonly conducted in physical education and may be the predominant research approach in health education or public health studies. It is conducted in exercise science, but not as commonly as in the other disciplines that I just mentioned. The different types of descriptive research include survey research, probably the most common, where we send a survey out to a large number of people and use that with some descriptive statistics to describe what we found. We also see descriptive research in developmental research, such as the longitudinal approach, where we look at the same people as they get older, or the cross-sectional approach, where we look at people at different ages to try and map out some kind of sequence. Case studies are also a form of descriptive research. Also, correlational studies are a form of descriptive research. Survey research is the most common type of descriptive research. This involves questioning techniques for data collection. It consists of asking questions of a hopefully representative sample of the desired population. The people who answer the questions in these surveys are called respondents. And the most difficult part of this type of research is writing those questions on the questionnaire. A census is a special kind of survey which obtains responses from the entire population. And if you click on this link, you can see some census data from the different states, including North Carolina. So we use descriptive statistics with descriptive research to organize, simplify, and summarize the data that has been collected. It typically consists of a set of scores called a distribution. The scores result from the measurements that are taken in the study. The original measurements or values in the distribution are called raw scores. There are a variety of computer programs for statistical computations and presentations of descriptive data. The one that I use the most is called SPSS, which is expensive, but actually as a UNCW student there is a free version of SPSS that you can use on Tealware. Descriptive statistics as well as some lower end inferential statistics can also be computed simply on Excel spreadsheets. So let's look at an example of some descriptive scores. Here's some test 1 raw scores from a distribution of scores from a test that I gave in a class. It doesn't matter what class, but the test was out of 20, although I did offer a half point extra credit question. But here's the distribution of scores, and it's in a weird format like that because I copied and pasted out of a Excel spreadsheet, and that's how it put it into a PowerPoint slide. But you can see that person 1 got 19.5 and person 2 got 19, student 3 got 13.5, all the way through for the raw scores. Well, that's interesting. That shows me all the scores, but I need to do something with that information. And that's what descriptive statistics allows us to do. It's not telling me whether I can make any inferences from the sample to the population. It's just describing what I found. So by putting that stuff into Excel and clicking a few buttons, which you don't need to, so excuse me, yawning there. For this class, it's not necessarily that you know how to learn Excel, but it's really easy. If you just go to Google or YouTube and type in descriptive statistics with Excel, you'll find a 2-3 minute video tutorials on how to do it, and it's very simple. So Excel, all I did was put all those raw scores into one column, hit a few different buttons as options, and then it turns out these types of descriptive statistics. It tells me that the mean was 17.2. It gives me the standard error, the median, the mode, the standard deviation, a few other scores including the range, the minimum to maximum, which is where the range comes from, and the count of 69 students in that class. That can be useful information. It describes the scores in our sample. So in Excel we can do descriptive statistics, we can do correlational statistics, and they can also produce some graphs which we call histograms, which show us a graphic representation of the descriptive scores that we are looking at. Excuse me for 1 second here. Okay, so I think we've looked at this example study before. This was looking at the 40-yard run times of some football players who were grouped by position and also by starter versus reserve status. So these scores here, let me just get the pointer option on here. Okay, so you can see for the different positions it's broken down starter versus reserve. So you can see for the 14, N is a number, starters who were backs, that for those 14 the average 40-yard sprint time was 4.7 seconds. For the reserves it was 4.914 seconds for the 14, and there were 28 total in those two groups. So what does this tell us? Well, by looking at the descriptive statistics, it seems to indicate that the starters, their average time of the 14 was quicker than the reserves. Well, you'd probably expect that, right? You'd probably expect your starters to be quicker than your reserves. So that's describing the scores, but it doesn't tell us if that is significant. The same thing for the linemen. Okay. Interestingly though, for the 14 in these two groups, the reserves were faster than the starters for the linemen. Maybe that's because the starters were bigger, heavier. That's probably more needed as an attribute, muscular strength and power, than 40-yard speed time for that position. So maybe that's not surprising. So you can see here, if we go down to the bottom, and this includes all of the starters, 42, and all of the reserves, that on average the mean was just a little bit quicker for the starters than it was for the reserves. However, we saw something different with this group than the other two group positions. So these are descriptive statistics. They can be interesting. They can tell us important information. I'm not trying to brush these scores off because they are important. But what they don't tell us is if there's any significant differences going on. So putting all that into a simple graph, here's our starters over this side, and here's our reserves on this side. And you can see by position, here's our first position, the backs, that the starters were quicker than the reserves, and we saw the same thing for this position. However, for the linemen, we could see that the reserves were faster than the starters. All of this is statistics, and it's just descriptive statistics, because it's telling us, basically describing our distribution of scores. So it's just describing the characteristics of a group. So let's look at some different types of descriptive statistics. The first group is known as the measures of central tendency, and this is taking you back to maybe high school statistics classes. This should be a review at this point. The mean is the sum of scores divided by the number of the scores. We typically use this with interval or ratio data. The median indicates the middle score. We use this more with ordinal data. The mode is the score most frequently received. So for example, in this distribution of scores, we can make some kind of statements about the mean. Well, we just add all these up and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. The median, these are, looks like they're all in a sequential order already, so it would be the middle score, which looks like it would be 6. And then the mode is the score most frequently received. It looks like it would be bimodal with 7 and 4 happening twice. Measures of variability. Measures of variability. Let me find the page in the book where I'm following along with some of this stuff. No, I can't find it. Bear with me here for 2 seconds. I thought there was a better section on the book than that. Okay, we'll move ahead. Let's take, pretend we got 2 groups, Group A and Group B. And there's probably a lot of scores in these groups, but I've just taken 3. Participant 1, 9, 2 got 1, 3 got 5. Maybe these are scores out of 10. This is Group A. Here's Group B. First person in Group B got 5 out of 10. Second person 6 out of 10. Third person 4 out of 10. Okay. We can use measures of variability to describe the differences between these two groups. And this is descriptive statistics. So in measures of variability, we're looking for the spread of the scores. We can look at the range from the highest to the lowest, 1 to 9 or 4 to 6. And we can also look at standard deviation as a measure of variability. So the standard deviation is the amount that all scores differ from the mean. And a low standard deviation means that the scores are near the mean. So just by eyeballing these two examples here, I would say that this group here has a low standard deviation because all of the scores, there's only 3 of them, but all of the scores are close to the mean, which we know is going to be 5. However, in this example, we know that their standard deviation is going to be higher because even though the mean would be the same, it's going to be 5 because it's 15 divided by 3. These two scores differ quite a bit from the mean of 5. This group over here also has a mean of 5, 15 divided by 3, but each of these scores is very close to that mean. So there's a nice formula out there, here it is up here, that we can use to calculate standard deviation by hand. And you might have already had to do this in some of your statistics and measurement classes. For example, if we took that group, I wonder if I can change the color of my highlighter here. Yep. So we got the same scores, okay, and here they are in this table here. So, and I'm not going to ask you to calculate this on any kind of test, but I want you to understand where standard deviation comes from. So first thing we do is work out the mean, and we would just add all of those up and divide by 9. Then we subtract the mean from each of the numbers in the question or in the distribution and square the result. So we'd subtract this from each one of these scores and then square the result, which are these numbers at the bottom here. Okay, and this is just following along this formula. Then we'd add up all of these, which is this part of the formula up here, and then we divide that number by n minus 1, which is this part of the formula here, and then finally we'd do the square root part to give us this number here. So the standard deviation for this distribution of scores is 4.8. Now that's a lot of work. I don't know about you, but I really don't want to be squaring numbers and subtracting and dividing and square rooting and blah blah blah. Whew, that's just a lot of work. It's important you understand how we get there. Well, it's actually more important that you understand that standard deviation is a measure of variability about how far each individual raw score is from the mean. But we don't really necessarily have to understand all this formula stuff, because Excel does it for us. So all I did in Excel was to plug those 9 scores into an Excel column, click a few buttons, and again, if you Googled standard deviation on Excel on YouTube, there'd be a tutorial there for you. Excel did the same thing. It gave us the mean, 10.22, which is the same as up here. It gave us the standard deviation, 4.17665, which is the same thing pretty much, just rounded up as 4.18. So Excel did the same thing I did, just with software, or with its own software formulas in the background. So that's important information. Standard deviation tells us the variability or the spread of scores of each individual raw score away from the mean. In terms of relationships among variables, this is where we start talking about correlational statistics. And And I'm sure you're pretty familiar with correlational statistics. I think you've seen them in another class. Correlation is just a family of statistical techniques that are used to determine the relationship between two or more variables. We know that the correlation coefficient always ranges from -1 to +1. We use scatter plots as a type of graph to illustrate the relationship between two variables. And that correlation provides information about the magnitude and direction of a relationship, but does not imply a cause and effect relationship between the two variables. I'm sure you've heard that before when talking about correlation. Being very important that that correlation coefficient doesn't allow us to state that one of those variables causes the other one. So again, let me get a quick drink here as we prepare to jump into this formula. So look at that formula on the slide. So I created some dummy data here where I wanted to take some reading readiness scores of 5 people and then correlate it to their achievement scores on some kind of reading test. So we've got two variables, X and Y, 5 participants, and I want to know what the correlation is between these two sets of scores. Now, there is one heck of a formula out there. Here it is. And you may have already done this in hand in other classes. But it's not that hard. It just involves adding some things up and subtracting and square rooting, etc., etc. And you're all smart people. You could all take these numbers through this formula and come up with this correlation coefficient here. However, as you might have guessed, we can just do this in Excel. So all I did was plug those scores into 2 columns, hit a few buttons. It gives us the correlation between column 1 and column 1 is a perfect 1. Well, duh. Same with column 2 to column 2. What we're interested in is column 2 to column 1, the correlation was 0.75. The same thing that we figured out here by hand, plugging through the formula. And the reason I show you both of those is to show you that this number is not coming out of thin air, that the software is using the formula in the background. So we talked about these scatter plots that show the relationship between 2 or more variables. So you can see here, here's our X variable and Y variable, and here's our individual scores. So you can see that this demonstrates a high positive correlation between X and Y. As X goes up, Y goes up about the same rate. Here's a low positive correlation between X and Y, because we still see that pattern, but it's more spread out. Here's no correlation. Here's a low negative correlation. As Y is going up, X is going down, and vice versa. Here's a high negative correlation where they're more grouped in. So I know you've seen these before, and it's assumed that you've had this content before this class. So that concludes the descriptive lecture.